Welcome to homework.
Okay, to determine what went into creating a Cross Aldol product, we simply need to do the following. I'm going to redraw the molecule, but with a pH instead of the phenyl. We simply need to identify the alpha hydrogen the alpha carbon that neighbors both the carbonyl and the newly created alcohol, which I will label in blue. This is our alpha carbon that we're interested in. And we sever the bond to the carbon that bears the OH. We can redraw what we've got on the right, the ketone side, if you will, or the aldehyde in this case. And then we redraw the left, but instead of an OH, we draw it as a double bond to oxygen. So, and that's essentially it. That's all we've got to do to determine what the starting products were. This would be aldehyde 1, and this would be aldehyde 2. Yeah. And as for reaction conditions, typically we just want some acid and heat. Okay. Now we've got to determine the Wittig reaction that happened. So the same idea, but it's a Wittig product, right? So for this, that's not a very good cyclohexane. Let's try that again. Take the product. And we're just going to sever the double bond, right? Once we've severed the double bond, then we can redraw one side as follows. So we're going to have a ketone on one side. And the other side is what will have been our Wittig reagent. And then we're just going to have to determine how to make that Wittig reagent, right? So the ketone we could just give, and then we need to determine how to make this from an alkyl halide, which is what will go in the preceding two boxes, alkyl halide, and then right, so this goes in the Wittig reagent box, and we're about to determine what goes in the alkyl halide and reaction condition boxes. Let me, can I bring this down with me? Yeah, perfect. Okay, so how do we make this from an alkyl halide is the next question. So basically all we've got to do is sever this bond and replace it with the bond bromine, and then react it with triphenyl phosphorus, right? So we'll just redraw this with the bond bromine, right? And then our reagent is just going to be triphenyl phosphorus, and we'll need to follow that up with butyl lithium, right? So I don't know how they've drawn this in. Okay, so we'll do it. It's like a two-step process, right? So first step would be reacting with the triphenyl phosphorus, and then the second step would be N-butyl, and that's to deprotonate and create the double bond. So basically what happens is that it's a displacement and SN2 reaction as follows. And then the N-butyl lithium will come and deprotonate to create the double bond. Oops, I drew that at the wrong. Dropped a carbon there. I Apologies if you're wondering about that. Right. And then therefore we're interested in this carbon for the N-butyl lithium. All right, either case, once we've created this sort of proto-ylide, the N-butyl lithium will come and create the double bonded version that is our actual Wittig reagent. Right. So altogether, you would draw this as your alkyl halide, and then the reaction conditions would be the triphenylphosphorus followed by N-butyl lithium.